Hi everyone, welcome back to Golden Wings Little Birds, where we make maths meaningful and manageable. Today we're diving into a powerful concept used all across mathematics: spaces. But wait, we're not talking about outer space Milky Way, we're talking about mathematical spaces. So what exactly is a space in mathematics? Let's break it down step by step.
In maths, a space is simply a set, a collection of objects, but with extra structure added to it. This structure allows us to do useful things like measure distances, define limits, or work with vectors and functions. Think of it like adding rules to a playground. Suddenly the space becomes more meaningful.
Let's start with the basics. Sets. These are the most basic spaces, just a collection of elements with no special structure. Topological spaces. Now we add a topology, a way to describe which subsets are considered open. This helps us define important ideas like continuity, convergence, and neighborhoods. Metric spaces. Here, we introduce a metric, a function that defines the distance between any 2 points. Metric spaces give us a more intuitive feel for how close things are. Next up, we have vector spaces, also called linear spaces. These are spaces where we can add vectors and multiply them by scalars. They're essential in both pure and applied maths. Let's look at a few important examples. Euclidean space. This is your classic 3D space, or n-dimensional real numbers. It has an inner product, letting us measure angles and lengths. Hilbert space, a generalization of Euclidean space to infinite dimensions. It's super important in functional analysis and quantum mechanics. Banach space, a complete normed vector space, meaning every Cauchy sequence converges. These are used a lot in real analysis and differential equations.
Now let's talk about function spaces, where the elements are functions, not just numbers. Two important families are LP spaces. These consist of functions whose pth powers are integrable, used heavily in real analysis and probability theory. Hardy spaces. These show up in complex analysis and signal processing. They involve holomorphic functions with bounded average size over circles or regions.
So to recap, a space in maths is just a set with structure. We looked at topological, metric, vector, and function spaces. Each type of space helps us describe different mathematical ideas, from convergence to distance, from functions to infinite dimensions. Understanding these spaces helps build the foundation for deeper maths, whether it's calculus, analysis, geometry, or even quantum physics.
If this video helped you, give it a thumbs up and don't forget to subscribe for more maths made simple. Got a question, or want us to cover a specific type of space? Drop it in the comments below. Thanks for watching Golden Wings Little Birds, where we fly through maths, one concept at a time.